Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling Podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you got to ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Welcome to After Hours Live. Ask your favorite RCDD. That would be me. Your favorite questions. So make sure that you submit your questions in the comment section. Got a whole bunch of great stuff going on for tonight's show. And I want to make sure that I try to get everybody covered as much as possible. As much as possible. So, we always start off every show with what? What's that first question we always start off with? Could it be, what are you drinking? What are you drinking? So Chuck is drinking ginger ale. Ginger ale. And it's been sitting for so long, the ice melted. Yep. So tell us in the chat box, what are you drinking? Let's kind of see what's going on with everybody tonight, right? Hey, is there a difference between ginger ale and ginger beer? I don't know. If you know if there is a difference between those two, let me know. Let me know. And before we get on with the rest of the show, make sure you subscribe to our YouTube channel. We just breached 300 subscribers on there, and we're on the continual push to keep everything going. I'm also on TikTok as well. Just started doing that one. And we just breached 600 followers on TikTok. So if you're on TikTok, there's a good low voltage presence there. So make sure that you hop on there, right? So let's see if some people are starting to pipe in. So Cable Dog Supreme, he's had one of those days. I'm sorry to hear that, Cable Dog Supreme. I certainly wish you the best. And Fernando is in the house. And Fernando says hello. Fernando, what are you drinking? I'm drinking ginger ale. Ginger ale. And I'll pose the question again because some people have come in. Is there a difference between ginger ale and ginger beer? I saw some ginger beer at the grocery store the other day, and it's in Ed Sheeran sings about ginger beer in one of his songs. And I was just wondering, is there a difference? It's not alcoholic beer because it wasn't sold in that section of the thing. But hey, if you know the difference between ginger ale and ginger beer, let me know. I want to learn. So Steve is in the house. So hello, Steve. Welcome, buddy. We got a test question tonight, so hopefully I'll get it right. If not, let me know in the chat box. And then, of course, Mark is in here as well. Mark, do you have your cup of coffee or your tea with you? So the usual crowd is here. So let's start off with the next thing. We all know what the next thing is going to be, right? Right? If you don't know what the next thing is, you haven't been around long enough. The acronym challenge. This week's acronyms have been the letter Q, if you actually been following me on LinkedIn. The problem is there's not a whole lot of acronyms that begin with the letter Q. There was literally 5 in the book. So I had to save them for the LinkedIn profile. So I couldn't do a Q in this week. So I'm doing RBB because that's going to be one of the next ones we're going to be doing next week. So the next week will be in the R's. So what does RBB stand for? Anybody know? I'll give you a hint. It has to do with bonding and grounding. So Cable Dog Supreme has it. He says rack bonding bus bar. Very good. Very good. Good job. Yes, you are absolutely correct. Rack grounding bus bar. Now, here's the thing about rack RBBs. They can be either vertical or horizontal, right? Vertical or horizontal. If you're doing shielded patch panels, here's a trivia question. Let's see who knows this. If you're doing a shielded patch panel solution and you have a rack bonding bus bar, should you use the vertical one or the horizontal one? Which one would be better? You could, well, literally you could use both, but which one is better? The vertical rack bonding bus bar or the horizontal rack bonding bus bar? Which do you think would be better for shielded patch panels? I'll give you a second or two to answer. I'll do my Jeopardy theme music. Do 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 do. The best way is vertical. Vertical, and the reason for that is you want to keep all of your conductors as much as possible close to the same length. So if you do a horizontal bus bar and you got a bunch of patch panels underneath that, each one of those bonding wires that comes up to the bus bar is going to be a different length, right? That could be a potential problem for the shielded cable plane. So the vertical one is actually better. The vertical one is actually better, but technically you can use both. But if you give it a choice, but we generally don't use RBBs because they're expensive. That's a big chunk of copper, right? So Cable Dog says, what is vertical? Vertical. Did I misspell it? So horizontal means it goes with the horizon. Vertical means it goes up and down. So the vertical RBB would mount to the rail on one of the patch panels, on one of the relay racks. Like I said, they're kind of expensive to do it that way. What a lot of technicians will opt to do is they'll take that bonded conductor, and then instead of attaching it at the top of the rack, they'll take it all the way down to the bottom and then attach it. And then they'll just run short jumpers over from each shielded patch panel to that vertical conductor. That way you don't have to buy that vertical rack bonding bus bar, which, like I said earlier, can be kind of very pricey, right? So, okay. I misunderstood you there, Cable Dog Supreme. He said he was answering in the theme of Jeopardy. I did a Jeopardy theme music. Oh, duh. Sorry about that, buddy. All right, so let's get on with the questions for tonight's show. So, like I said, if you do have questions, make sure that you put them in the comment section. So, I got a really great question from Aaron on YouTube, but I'm going to answer that one last because that's the longest answer. So I'm going to do that one last. I just want to let Aaron know because he usually hops on. I just want Aaron to know that I am going to answer it, but it'll be the last one. So the question I want to start off with is, boom. There you go. I have a cable fail due to insertion loss. How do I fix that? Well, if I had Steve on, Steve would tell you. He's in the chat room. I saw him talking, but I don't have him on as a guest tonight. Insertion is just, us old guys used to call that attenuation. So as that signal goes down the cable, it gets weaker because of the opposition of flow to current. So the signal gets weaker and weaker and weaker and weaker and weaker. So what it means is if you're feeling insertion loss, you're having too much loss somewhere. What could really cause problems with insertion loss? Now, I'm going to give you a few things to look at, but they are not in any particular order, okay? Except for maybe the first one. The first one I would always check is how long is the cable? How long is that cable? Because if it's over 295 feet, right? Because remember, that's our permanent link length number. You're going to have too much insertion loss, and that's going to cause that. So that'd always be the first thing. And the biggest culprit for those are slack loops. Slack loops, yes. That's why you want to make sure that you keep the slack loops to, like 10 feet in the telecom room and as short as possible. Because if you have too much, you can have too much insertion loss. It could also cause some other issues as well, especially if it's Cat 6A. So yeah, you make sure it's not too long. So verify that first. Just walk it off. If you got a set of prints, just measure it off so you make sure that they're not too long. And then the next thing you want to do is maybe look at the patch cords, right? What are the quality of the patch cords? Are they in good shape? Are they something exceeding the bend radius? Do the patch cords match the category of rating for the cable, right? So you want to look at that because that could be another big issue there as well. And if this cable is in a conduit, and they used pulling lubricant. Excess pulling lubricant can cause fail in insertion loss, with insertion loss, I mean. So that's another one you got to really, really watch out for. And so, Steve, if you come up with any tips to help serve insertion loss, let me know in the chat box, and I'll throw it up on the thing as well. And then another one, too, and this one hopefully is not so much of an issue, make sure the tester is set up correctly. Right, Steve? Make sure the tester is set up correctly so that way it's not causing any problems. And then the last thing I would look at is I would look to make sure that all of the components match. If the cable's Cat 6A, you better make sure those connectors are Cat 6A. You better make sure it's a Cat 6A patch panel, right? Generally, like I said, though, usually it's because of excessive length and then probably cable pulling lubricant are the two most common that I ran across when trying to solve insertion loss issues, right? So there's your question for insertion loss, right? And Steve says, bingo. So I got the stamp of approval from my AEM test expert. He said I nailed it. So good job. Glad to know us RCDDs all have the same thing. So, oh, by the way, I got a real cool show coming up soon. Steve and I are collaborating. I took some cables and I terminated one with 568A and another one with 568B. And we're going to look at those test results and see, is there a performance difference between those two? We're also going to look at some cable from your big box store, some Cat 6 cable, compared to like a brand name Cat 6 cable. And we're going to say, is there a difference between those two? And Steve and I are collaborating on that. That show is going to be coming out within a couple of weeks or so. So pretty cool stuff coming up, right? So the next question is, let me see, where is it? Dun, dun, dun. Boom. Here we go. This question was a little bit longer, but I had to paraphrase it down because I got a limited number of characters that I can do within my feed there. But basically, what Darren from Northern Virginia says is, Chuck, he has a customer that they want their fiber to have a red jack, and he said their fiber was OM3. And he realizes that the standards say that the jacket should be aqua. And he goes, what do I do? So keep in mind, standards are voluntary. I'll say that again. Standards are voluntary. So a customer does not have to follow the standards if they don't want to. It's not like the code book, but it is in their best interest to follow the standards because it's going to make sure that their cable plant performs, is interoperable, and is thinking about the future if they follow the standards. Now you probably wonder, well, how does changing the color to red help me for the future? It doesn't, but I'll tell you where it does help you. And I had this happen to me one time. Let's say that, for example, that you got a customer that you pulled cable for a couple of years back, some fiber cable. And they called you up and they said, hey, we want some more fiber cable in. Can you come out and put them some more? And you can't remember what kind of fiber that you used, right? But you just happen to have one of your apprentices right down the street picking up some equipment. So you call your apprentice and say, hey, go up to Dewey, Cheatham, and Howell Law Firm and go up to the 5th floor and look in the telecom room, look at the fiber optic cable and tell me what color is the jacket. If they follow the standards and it's aqua, then you know what it is. If it's yellow, you know what it is, right? If it's red, well, then that apprentice who may not know how to read a cable label may not know what that fiber is. Now you have to go out there and do it. So there are some advantages to following it, but keep in mind standards are voluntary, so you don't necessarily have to follow the standards if you don't want to. So let's go ahead and tackle the big question now from Aaron. And so again, I paraphrased it down here to a tiny little bit. Let me put on my glasses. I'm going to read you this whole question, right? So, and he sent this to me on YouTube in a comment on one of my videos. He says, when deciding where to put the pathways, what are some of the main things to consider? Do you ever reference the HVAC prints? Is it ever okay to cut through some rooms? Any particular height above the grid? And any tips for new installers? Now you see why I couldn't put it in that little section, right? There's a lot of stuff going on with that question. So I thought about this, and I actually thought maybe I might want to just go ahead and make a whole entire show out of this, but I didn't want Aaron to necessarily wait for me to produce a show on this stuff. So I'm going to go ahead and answer it here, but I might come back because I'm only covering part of designing a pathway system of what's going to do, right? So the first thing you really want to do is you want to figure out, okay, is this pre-construction or post-construction, right? Are you doing it while they're building out the facility, or are you doing this after the customer's already moved in? Because those will weigh a lot on your deciding process and what you want to use. When you look at pathway systems, generally they're going to come in two varieties, right? Continuous pathway support, such as conduit, ladder rack, cable tray, or non-continuous support, J-hooks, bridle rings. Yes, Chuck said bridle rings. You can use bridle rings, just not on data cabling. If you've got interduct, right? And you got fiber inside that inner duct. You can use a bridle ring for that. So bridle rings do have their place. Just don't use them with data cabling because, well, we'll talk about why in just a second. Never use bridle rings for high performance data cabling. So now let's look at the pre-construction while the construction is going on. What are some things that you're going to want to do? The first thing I'm going to want to do is if I'm a foreman, I get assigned to a job, I'm going to want to have copies of every set of prints on the job. The HVAC prints, the electrical prints, fire alarm, modular furniture prints. I want all of them. All of them. Because you might be pulling cable before the modular furniture is being placed. And that's going to be a key factor in a minute. I'm going to talk about that in just a minute. You're going to want to know where the major ductwork is going to go down. What hallways are they using? What height are they going to be mounted at? You want to know where the electrical cable is going because you want to have separation from EMI and RFI. Those are critical things you need to know, right? And so the best thing to do there is ask your office to get a set. Now, I'm going to tell you right now, it's going to cost money to get those sets because they're not going to just give them to you. 90% of the time, they won't give them to you. Sometimes the customer will give you a set of prints as part of the bidding process, but most of the time you got to buy your own set of prints. And I'll tell you right now, it's going to be several hundreds of dollars, up to $500. I've once paid $1,500 for a set of prints, right? But that think of it this way: it's an investment to keep you from having a mistake. Then the next thing you want to do here's pro tip number 1 for the night, right? Attend the weekly GC meetings. Attend the weekly GC meetings, right? Again, we're talking about you doing this while the construction is going on. Sit in that meeting. Don't blow it off. Pay attention. Listen to everything, right? Words. And then when they kick out the meeting minutes, review the meeting minutes. Make sure that they accurately reflect what was going on, because those meeting minutes will become the legal documentation in case there's any disputes. Had this issue happen one time with our cable getting painted, right? We didn't discuss it, and somebody put it in the meeting minutes because it was part of the template, and we didn't discuss it. And long story short, just causes lots of problems. And don't be like Chuck. When you're sitting in those weekly GC meetings, ask questions. Don't be afraid. The only stupid question is one left unasked, right? So ask those questions and get them documented in those meeting minutes. Get them documented. Remember I told you the 3 most important things in our industry: documentation, and the last one is documentation. While you're in that GC meeting, especially the first one, introduce yourself to the lead person, the project foreman or supervisor for all the other trades, right? Find out who the lead guy for the electricians are and introduce yourself. Because if you know that person and you have a good communication pathway between you two, that's going to help you solve a lot of problems quickly. Here's another pro tip. Pro tip number 2 for the day. Especially if you know this is a longer project and it's going to be done, say, near like the holidays or something. Find out what that foreman likes. If he likes to go shooting, buy him some range time. If he likes beer, buy him a 12-pack of beer. If he likes whatever. Because again, that just helps you build that relationship. One thing I've learned in this industry, above everything else, above experience, above knowledge, relationships. Keep that in mind. Yeah, make sure that you understand that, right? So make sure you introduce yourself to them and they get a good working. That way, if you get to the electrician, say, hey, look, some of your cables are kind of like, come here, can we reroute this stuff? And if you have that working relationship with them, there's more likely that they'll get them to have that change that for you, right? Now let's shift. Let's talk about in an occupied office space. So in an occupied office space is going to present more of a challenge for you to put in a pathway system because you're going to have to be dealing with an office, and some customers are not going to want you there during day hours and want you there a second shift or third shift. The cleaning is more intense because on a new construction site, all you're really doing is just broom sweeping. In an existing office space, you're going to be vacuuming carpet. You're going to be dusting off desks. You're going to be making sure everything gets put back correctly. You're going to make sure, pro tip number 3 for the day, that none of your technicians stood on anybody's desk. Ask me how I know that one. Yeah. So you might want to make sure that you have tarps and a vacuum cleaner and some pledge, because you want to leave, and you want to make sure you emphasize this with your guys when they're doing work in the ceiling, especially putting in pathways, that when they go into an office to do some work, they should leave that office not as clean as, but cleaner than they found it. Cleaner than they found it, right? So when you're designing a pathway system, whether it's pre or post construction, make sure you plan for the future. Plan for the future. Plan for future expansion. The average lifespan of a building is 50 to 75 years. Average lifespan of a structural cable plant, 7 to 10 years. I'm going to forewarn you guys now. We're probably going to go just a tad bit past 30 minutes because I'm only on the second page. Yeah, so the building will last 50 to 75 years. The average structural cable plant lasts 7 to 10 years. So let me ask you guys this. So we're up to Cat 6A cable now. Well, Cat 8, but Cat 8's really for data centers. What size is Cat 10 going to be? What size will Cat 10 be? Nobody knows. So you got to plan for that. And how many times have you had a customer literally the day after the cutover call you back because they forgot the wireless access points because they thought they were wireless? My days, it used to be the fax machines. Oh, we forgot the fax machines. Can you come out and run some more cable? You got to leave room in that pathway. You don't want that pathway filled up 100% from the time you get done, right? 30% growth is a good number to shoot for when I talk about pathways in the ceiling, right? When you're trying to decide where to place the pathways for the trunk, for the cable pathway, for the trunk, the main branch, it's going to hold the bulk of the cables. Try to go down main hallways. Don't go over top of modular furniture if you can. Try not to go over top of a row of offices if you can. There's going to be some times you're going to have to. You might have something in the ceiling like ductwork that's going to force you to do that. But when you can, that's why you want them. That's why you want the modular furniture print, so you know where that modular furniture can be put up. Because that modular furniture is not set up while you're pulling cable most of the time. So that way you can figure out where that main hallway is. And the reason you want to come down the main hallways is because now you don't. If you don't, and you come down over top of the modular furniture, you're going to have to open up tiles above all the modular furniture, set your ladder up in there, and you're going to be people working there. Just go down the hallways if you can. If you can, just try to stay down those main hallways. Right? That's going to make Mac work a lot easier. Right? But so it's not going to make your work any easier. But remember, same reason why we leave pull string, right? For the next person, for the next technician, because you never know. Might be you. The most common type of pathway support that you're going to install is the discontinuous support, right? The non-continuous support, J-hooks, right? So J-hooks, they're called J-hooks, is a piece of metal in the shape of a J, right? And, I was just thinking, so some of my future videos, I'm going to do some real live stuff I'm going to do with this. I got to get some J-hooks to mount around the perimeter of my office here, and a rack and a patch panel so I can run the cable around and turn my patch panels and faceplates, and I can actually test things and cause things not to go, and I make videos about them for everybody. Just thought about that. Right? So the J-hooks, you want to make sure that you give yourself they give yourself plenty of flexibility, because if you're going down a hallway and there's an obstruction in a way, if you're doing J-hooks, it's real easy. You just kind of change path a little bit. If you're doing cable tray or conduit, that's already in place. You're not going to make a change in the field easily with that. You can make a change in the field, but they're just not going to be easy. Now, when you're trying to put in the J-hooks, you really need to think about what elevation do you want to mount them at. And this is where this HVAC print's going to come into play, right? Because they'll tell you what height those ducts are mounted at. If you mount your J-hooks at the exact same height as ducts, every time you come to a duct, you're going to have to go up and over that duct. Now, you're probably thinking, well, Chuck, that's only 1 foot. What big deal is that? Yeah, it's 1 foot up and 1 foot down times the number of cables. If you've got 500 cables going down that hallway, that's 1,000 feet of cable that was not estimated in the bid. So think about that stuff, right? You got to think about that stuff. So make sure you pick your elevation carefully. Also, another one to look at, fire sprinklers. What height are they going to mount their stuff at, their pipes? Because they typically will come in after we're done roughing in our cable, and then they'll put the pipes in anywhere. And if your cable even touches the sprinkler, guys, they will cut your stuff right off. When you're mounting those J-hooks, you want to mount them between 4 to 5 feet apart at random distances. Not every 4 feet, not every 5 feet. You want to randomize it. Maybe 4 feet between the first and the second. maybe 4.5 between the second and the third, maybe 5 feet between the third and fourth. The reason you want to do that, if you put cables inside of a J-hook and you overload it, it's going to crush those cables on the bottom. We'll talk more about that in a second. And if you put those J-hooks in at exact distances, let's just pick a number, 4 feet, because people like to do that 4 feet for some reason. If you mount those J-hooks exactly every 4 feet and you've got 200 cables in them J-hooks, those cables on the bottom are going to get crushed. And that's going to cause a dead spot at a certain frequency. That's called harmonic disruption. Okay. Steve, I'm going to have you on the show to talk about harmonic disruption one day. Right. So you want to randomize those distances. Now, when you think about J-hooks, they're called non-continuous because there's nothing supporting the cable between those J-hooks. So there's going to be some droop. Droop is okay. The thing is, you don't want to have them droop more than 12 inches between those J-hooks. And you want to have at least 4 inches. So you want to be somewhere between 4 and 12, right? If you have more than 12 inches of droop, there's a lot of weight on them cables, and they're going to crush those cables even more. If you have less than 4 inches of droop, the cables are too tight. You've stretched them. You stretch the copper. You're changing the physical characteristics of the cable, and that could cause you problems when you go to test that cable. So generally, you want to shoot between 4 and 12 inches. Can you place the J-hooks closer together? Absolutely, you can. Absolutely, you can. But make sure that you talk to your project manager or your estimator first, because now they bid a certain number of J-hooks in that bid. And if you go over those J-hooks, that means the material price of the project goes up, and that means the labor price of the project goes up. So always ask for permission first before you do that. Right? So when you put in those J-hooks, you want to make sure that you look at those cables on the bottom, make sure they're not getting crushed. Okay, for that very, very reason. If they get crushed, then you're going to have a problem when you go testing cables. You also want to make sure that when you mount those J-hooks, that you put in your own independent support for those J-hooks. So there's a couple different methods here, right? Some people will use beam clamps, right? So it's just a clamp that you hammer onto the flange of the red iron, and then it's got usually a screw adapter, and then you can screw an all thread into it and put a J-hook to that. There's also another kind of beam clamp. I can't remember what it's called, but it's like in the shape of a C, and then there's a nut on the top of it, and you screw it down. It's like a vise, right? It kind of bites onto the thing. Both of them will meet code. Both of them are fine. Just make sure that you buy one that's rated for the weight that you're going to put on there. And if you want to know the weight, just contact the cable manufacturer. They'll tell you what the weight is, right? So you can do that. You can also put in your own. Now, pay attention here. You can put in your own independent wire you install. Independent wire you install. You cannot attach a J-hook to a ceiling grid wire. That's a code violation. I know they make the bat wings for them. That's how you can attach them to your own wire you install. Now, the code book tells you, and this is where a lot of people mess up. The code book tells you that when you put in your own wire, both ends have to be anchored. Both ends of that wire have to be anchored. So one end you're shooting into the ceiling, or you're using a hammer-on beam clamp. The other end, where are you going to attach it? To the ceiling grid. You have no other place to go to. So you have to identify your wire as your wire. So paint works just fine. Just find a spot, spray paint them, whatever color. Or you can buy Airco or Invent, and I have one somewhere. Yeah, it's a little yellow clip that you snap onto it, and you can attach that as well. And then you can tell the inspector those are mine, right? So make sure that you put in your own wires and you support them. Okay, both ends have to be anchored per the code. If you don't, you're going to run into some problems. Pro tip number 4 for the day. If you're doing Cat 6A cabling or Cat 5E 22 gauge cabling, right? Bring those J-hooks closer together, generally about 3 to 4 feet apart. And you're doing that because Cat 6A cable weighs about 40 pounds per 1,000 feet, and Cat 5E weighs about 19 to 20 pounds per 1,000 feet. So it weighs twice as much. So you got to bring those J-hooks closer together to support those extra weight of that 22 gauge Cat 5E or the Cat 6A cable. So that's also, you want to make sure that you do, because you can never put in too much support, but you can definitely put in too little support, right? So now that leads us to how much should they be supported above the grid? So the grid says you cannot block access panels to include ceiling panels. So the code says that you have to have at least 3 inches of clearance above the grid. That's so you can get into the ceiling to do the work. That's so the inspector can get into the ceiling and do the work. And that's so the fire department can get into the ceiling, check for extension, right? That's minimum. If you go by Bixie's TDMM, it's going to recommend that you do 6 inches. So if you have the space, go 6 inches, but don't go less than 3. Okay, because if you do, you can run into some kinds of problems that you don't want to have to deal with, right? You can attach J hooks to all thread. Just make sure that you do it securely, like I was just talking about earlier. And here's another pro tip. And this one just came to my mind because I was thinking about all threads. Because some people will say, well, can I mount to the trapeze system that the electricians put in to support their J hooks? No, you can't. You didn't install it. You can't attach to it. But here's another one. And I've seen this happen a lot, unfortunately. Do not tie wrap your cables to an existing conduit, even if it's yours. It is a code violation, right? So now let's switch gears. There's our J-hook conversation. Now let's switch gears to cable trays and ladder rack, right? So you want to try to keep your bundles at least 3 to 6 inches away from the edge, especially if they got PoE going over them, right? And that keeps them from having kind of issues. Make sure that you use cable spillways to exit out of the cable tray because you're going to cross those rungs. If you got a big bundle of cables coming down, that's where it comes down. It's going to crush those cables. Let's say this is the rung. It's going to crush those cables. So do a nice spillway on that, so that way you don't cause damage to those cables on the bottom. Speaking of spillways, do the same thing with the sleeves. A lot of people miss that. So when you put in the sleeves that come into the wall, they'll have those cables come out and then literally kind of go like that, right? And then those cables in the bottom are getting damaged, right? They make spillways that you can attach to that gives you a nice sweep coming out of that sleeve, and that's going to save you some problems. When you get done putting in the cable tray system, don't exceed the maximum fill ratio of 25%. That gives the customer some more, like another 25% to get to the maximum of that system, 50%. Because remember, it's got to last 50 to 75 years. Because that cable tray is a part of the building components, not the structured cable components. Let me see. I had a couple more things I wanted to tag on before we call off. So don't stock the cables more than 6 inches in depth. And if you have to, you might want to use retaining posts on the sides of the racks to keep those in all nice and done, all nice and in there. And pro tip number 5, make sure that the cable tray is bonded to a ground. Okay, that's gonna be critical in there for you. And here's one for my buddy Todd. Make sure that cable tray is labeled. We just did an interesting show last week. You should check it. We talked about labeling stuff, right? You don't want those cables to be. I just thought of this. Here's a code violation a lot of people don't realize. It says in the code book that you can't put cables in a cable tray system until that cable tray system is 100% complete. A lot of times, that's another trade installing it for us. And a lot of times, I've done projects where we would be pulling cable while the electricians were still running the cable tray. But that's actually a code violation. If you get the right inspector, they're going to cause you all kinds of headaches. All kinds of headaches. I think that was the last page I had for this, which is probably good because we're already at our 30-minute mark. Let me just double check, make sure I didn't have any other notes. Yay, no notes. No more notes. Yay. So let me just check the chat real quick because we're at our 30-minute mark. I'll just see if anybody put any cool questions for next week, right? So red is a common color for fire alarm cable. Could cause an issue. You're exactly right. You might have an inspector that might give you some issues with that. So let me see. What was this question here? When should I use FUTP and SFTP? When you suspect there's issues with EMI or RFI, right? And you'll know that because you'll start having like computers all of a sudden just kind of glitching and rebooting themselves, or you have problems with drop signals and stuff like that. I'll answer that question more in depth next week because shielded cable is actually pretty cool because a lot of people don't realize that there's like 4 different kinds of general shielded cable that you can actually install. So I'm going to answer that one more in depth next week, Mohammed. Hope you come back and visit us. Right. So what was this one here? How many cables should go in the same bundle considering all the cables are taking PoE signals? Okay, so Mohammed, I'm assuming that you're probably not in the US. Let me know if that's correct or not correct. For us here in the US, in our code book, it actually tells us the size of the bundle that we're allowed to go to. unless it's limited power -LP cabling. But generally, 24 cables is about the max you want to do if you're doing power over Ethernet. Okay, because the problem is not interference with PoE, because you're actually using direct current, so it's not going to interfere with the other cables. The real true concern is heat. The real true concern is heat. So Brian is in the house. Hey, Brian, good to see you, buddy. So we're going to go ahead and log off. I did have a couple other questions that were asked here, so I'm going to make sure I roll them into next week's show. So make sure you stay tuned. And remember, knowledge is power. Take care, everybody.